We scan our faces to access our data. We ask voice assistants for the weather. We prompt software to write a business email, and the text appears instantly. Terms like machine learning, deep learning, and neural networks are frequently used interchangeably, which masks the specific jobs each of these technologies performs. To understand how these systems function, we have to look past the monolithic exterior. When we examine the architecture's nested layers, we find a structured hierarchy where each inner circle performs a specific mathematical calculation to solve human problems. The widest circle is artificial intelligence, the broad engineering goal of making machines perform human tasks. One level inside that boundary is its largest subset, machine learning. Traditional programming follows a rigid script. A human writes a rule and the computer follows it. Machine learning reverses this. We provide historical data, and it detects trends on its own, building logic that no human manually coded. Look at a bank evaluating a loan. Instead of a human officer weighing every factor, a machine learning algorithm analyzes thousands of past applications. By identifying the mathematical relationship between credit scores, salaries, and defaults, it can predict with high accuracy whether a new applicant is a safe bet for the bank. This pattern recognition happens in three distinct ways. Supervised learning uses data that is already labeled. Unsupervised learning takes messy, unlabeled information, like thousands of random news articles, and clusters them into topics. And reinforcement learning uses rewards and penalties, allowing a model to learn a game like chess by maximizing its score through trial and error. This shift moves the burden of logic from the programmer to the data itself. As long as the information is organized into neat tables and columns, the machine can predict outcomes far faster than any human could. But most of the data we produce doesn't fit into a tidy spreadsheet. Standard machine learning fails when it encounters the chaotic reality of high-resolution images, audio recordings, or video frames. To process that complexity, we move one layer deeper to deep learning. This is an advanced subset of machine learning that uses a structure modeled after the biological neurons found in the human brain. This is an artificial neural network. It consists of three stages: an input layer to receive raw data, multiple hidden layers where the actual computation happens, and an output layer for the final result. When an image enters the network, it moves through forward propagation. The data flows through the hidden layers, where it is multiplied by numerical values called weights. These weights prioritize certain features of the image, leading to an initial prediction. Because the first guess is often inaccurate, the network uses backward propagation. It compares its prediction to the correct answer, calculates the loss, and sends the signal back. The network then adjusts its weights to reduce the error next time. By repeating this cycle millions of times, the system learns to interpret the visual and auditory world automatically. It gains the ability to see objects or hear words without a human ever having to define what those things look or sound like. At the very center of this architecture is generative AI. While the outer layers focus on classifying or predicting existing data, this core layer is designed to produce net new content, whether that's text, realistic images, or functional code. The tools we use most, like ChatGPT, are powered by large language models. These models are built on a specialized architecture called transformers, which changed how machines process human language. Transformers use a mechanism called attention. Instead of reading a sentence one word at a time, the network analyzes the entire block of text at once. It calculates the contextual relationship between every word in the sentence, assigning a score that tells the model which words are most relevant to the meaning of others. This mathematical mapping allows the machine to mimic human reasoning. By calculating the context across billions of documents, the model can generate conversational responses that are both statistically likely and remarkably coherent. The technical mystery is now an architectural blueprint. Artificial intelligence is the objective. Machine learning extracts patterns from structured data. Deep learning processes complex media. And generative AI uses those foundations to create new content. This logical framework manifests in the coding assistants, navigation apps, and recommendation feeds we use daily. It is the invisible engine powering the modern digital experience. By identifying these nested layers, you shift your perspective from that of a passive consumer to an informed user. You no longer see a mystery. You see the mathematical engine shaping the world around you.
धन्यवाद दोस्तों। इस वीडियो को देखने के लिए आपका दिल से शुक्रिया। अगर आपको यह वीडियो पसंद आया हो तो कृपया इसे लाइक करें, शेयर करें और हमारे YouTube चैनल को सब्सक्राइब करना बिल्कुल न भूलें। आपका प्यार और समर्थन हमें ऐसे ही नए वीडियो बनाने की प्रेरणा देता है। फिर मिलेंगे एक और मज़ेदार वीडियो के साथ। तब तक के लिए नमस्कार।